Hey everybody, welcome back to Enoch's channel. Today I've decided that we will spend more time on the algebra course for you to familiarize yourself with certain algebraic expressions. Now, I would like to show you 3 rules of algebra that you must know so that you can do your question papers. The first rule, ax times a to the power of y is equal a to the power of x plus y. Now, we have an x here and we have the y here. Now, I will make it x plus y. Some of you may be thinking, how does this equation work? Let me show you. Now, in this place here, I have the letter x. So I am going to list this as x number of times. And here is the green. So I actually have y. So this is also y number of times. So through this video, I will show you examples of where we can use such equations. Some of you could mistaken this as a to the power of x, a to the power of x times y. It is not like that. Through this reasoning here, I hope you have understood how this equation works. Let's move on. Now, this is rule 2. A to the power of x is to the power of y is equal a to the power of xy. This is how it works. Let's say I have 3 to the power of 3 to the power of 2. It is simply 3 to the power of 3 times 3 to the power of 3. Now, here, when we have this 3 to the power of 3, if we look back at here, a to the power of x times a to the power of y, we can actually say it's a to the power of x plus y. X I can name as 3 and y I can name as 3. This is how the algebraic expression works. Let's move on. A to the power of n divided by b to the power of n is equal a divided by b to the power of n. Let's see how this works. Now, this is written a n number of times. And this is also written n number. So if I can actually expand this out to get this kind of equation, then I can separate it out so that I can get a by b times a by b. Let's say I just have these two. It is easily equal to a divided by b squared. Now n can be any value to infinite. Alright, let's move on. Now here are a few examples where we will use these 3 formulas. This is taken from Singapore Mathematical Olympiad Senior Round 2019, and this is question number 2. Root 10 minus root 2 to the power of 1/3 multiplied by root 10 plus root 2 to the power of 7/3. Now this is how it actually works. I'm going to give you, take yourself some time. You may pause this video and try this question out. Alright, let's continue. Now I'm going to show you some clues that has been used. Now, first clue I can give you is, what can we do about this 7/3? Because it's a very horrible subscript. I can change this to either a proper fraction or a number. So this is where I can use the question model a to the power of n times a to the power of n, which is equal a to the power of m plus n. Let's look at the answer, shall we? Now this answer is a relative simple, so I'm going to go through it. Now, let's put root 10 as a and root 2 as b. I can make this a minus b to the power of 1/3 times a plus b to the power of 7/3. Now, let's answer this question. A minus b to the power of 1/3 times a plus b to the power of 1/3 times 2. Now, let's look at this part first. Now, this part was derived from the formula a to the power of x times a to the power of y, which is equal to a to the power of x plus y. Now, I have separated this, so we can take this small a as equal to a plus b. So this is how we get the first part. Alright? Second part is also the same thing. Now, because I want to focus now on this part, now there is one rule I have forgotten to mention. If we have a to the power of n times b to the power of n, it is actually equal to bracket a b to the power of n. So like that, I can put this as one side and this on another side, and I can put my subscript as 1/3. Now, for those of you who may not know how to work this out, it's very simple. Bracket a plus b to the power of 2 is equal to a square plus 2ab plus b squared. Now, in the future videos, I will come more in depth onto this topic, because this will use a concept known as Pascal's triangle and using of the binomial theorem. Now, we have this now, which we actually made. Now, for some of you who don't know, if we take a times a, b times b, then we have this way, and also this way, we end up with a square minus b square. Now Now that we are actually done with factorizing the entire thing, we can put them back. So a squared. Now, root 10 square is actually equal to 10. Good job. So, with here, I can actually get 10 and b squared. So, I end up with 10 minus 2 being 8. Now, 8 to the power of 1/3 is just equal to 2. Just for your information, all the questions I'm about to show you are not allowed the use of a calculator. So this is how we actually do it. Here's the same thing. 10 minus 2 root times root 2 plus 2. That is equal to 2 times 12. Where did I get 12 from? I got it from here, this 10 and this 2. So 12 minus 2 root 10 times root 2. So that is equal to 2 bracket 12 minus 4 root 5, which is equal to 24 minus 8 root 5. Some of you may be wondering, how did I get this 4? Now, it is actually simple. This root 10 actually is made, now root 10 is equal, now in primary 1 or level 1 or standard 1, you learned that 2 times 5 is 10, same thing. So it's just root 2 times, root 5. Then I take this root 2 and this root 2 and I can already form 2. And this 2 and this 2 make 4. And there we have the answer, 24 minus 8 root 5. I hope you enjoyed this question. Let's move on to the next question. Now this is from a similar question. This is SMO Senior Round 2017 question 5. Just pause this video and take some time to solve this question on the top. Simplify root 5 to the power of 3 minus root, oh excuse me, sorry, I apologize. It's not root 5, it's root 2. I am very sorry. Alright, root 5 minus root 2 to the power of 3 by root 5 minus root 2 minus root 5 to the power of 3 plus root 2 to the power of 3 by root 5 plus root 3. Please pause this video to attempt this question. Alright, let's continue. Now, I'm going to do the same method. Let root 5 equal to A and root 2 equal to B. I just also apologize, this is supposed to be root 2. So, A cubed minus B cubed divided by A minus B minus A cubed plus B cubed divided by A plus B. Now, some of you would have heard the method like 3 by 5 is equal 610. I can take the denominator and multiply by both sides, and I think this denominator multiply by both sides, and we will still get the same fraction. Using my method here, we can solve the question. So A cubed minus B cubed, if I take this, and we can multiply here and here, and then we take, okay, I use a different color. Okay, we take this, and we can multiply by here and here. Then we will be derived with A minus B, A plus B. I hope you understood that I have to multiply the denominators together. Then the A plus B, I take here A plus B, then I take to the numerator here. A minus b, I take to this numerator here. Afterwards, I can immediately answer the question. Now, a cubed times a to the power of 4, a is equal a to the power of 4. Now the reason I don't want to show the following steps is because you may have the idea this a cube and this a are positive. This negative a and a cube will actually cancel each other out, so I don't need to write that down. Same thing, negative b cubed plus b, so that'll be negative b to the power of 4, negative b to the power of 4, and here minus minus, so that's actually plus b to the power of 4. That is equal to 0, so that's nothing. So I'm actually left with a cubed times b. Now, some of you may be thinking how this works. It's a cubed times b minus ab to the power of 3 plus a cubed b minus. So this is actually equal to 2a cubed b minus 2a b cubed. I can immediately factorize the common terms. We have a 2ab and we also have a 2ab. So I factorize here. I'm left with a squared minus b squared. Now when I have common terms in the numerator and denominator, I will immediately cancel it out. It's useless. So 2ab is 2 times root 5 times root 2, which is equal to root 10. If you want, you may put this onto a calculator and you will realize that you actually get 2 root 10. Otherwise, you can take this entire equation, then also minus 2 root 10. You will get your answer as 0. Alright then, we have one more question. Now that's a very simple one. This is for SMO Junior 2005, question 27. For those of you who may not know what's the difference between junior, senior, junior is for 13 to 14, 13, 14, and seniors for 15, 16. Now I'm only a 13-year-old, but using the skills here, it is possible to solve any question. The senior one is for 15, 16, 15. Right? Now the previous two questions were for 15 to 16-year-olds, but this one is for 13 to 14. 2005 square plus m square is equal to 2004 square plus n square. What's m plus n? Please pause this video and take some time to solve this question. Alright, I hope you solved this question. Let's go. Now, the solution is very simple. Now, in the previous question, we saw a square minus b square. That is equal to a plus b times a minus b. Same thing here. 2005 square plus m square is equal to 2004 square plus n square. Now, if I minus 2004 square here, I can also minus here. So I get here. M square. So I minus n square m on this side. Minus m square. I will also minus m square here. So we have numbers on one side, letters on another side. Now, a square, b square, n square, m square. Let us factorize. It's equal to 2005 minus 2004 2005 plus 2004 is equal to n plus m, n minus m. Now, if you're wondering how to solve this, you can actually use this factorization method here, and you easily get 4009. Now, during a Math Olympiad, if you find a very big number, try to look for the factors. When I found it out, it was actually equal to 211 times 19. Otherwise, it can be 4009 and 1. However, this method will not work as you will get an incomplete answer. So the only possible answer would be 211 and 19. So n plus m we will get here, n minus m you will get here. And this is how we solve this question for m plus n to be 2011. So if you want, you can go ahead and find out what's the answer for m and n, but that's not really what the question is asking. Anyways, thanks for watching my YouTube video. Please subscribe to my channel. Thank you.